sa video natin ngayon, we will try to solve this problem using two methods. The first method would be using equilibrium equations, and then the second method is by using geometry alone, but in combination with the concept of Varignon's theorem. So let's begin. Ayan, we have three segmented cables, AB, BC, and CD. Then ito yung distances na binigay. Ayan. So first, we will draw the support reactions. Now, a concept you can use in segmented cables is sa location ng supports, 'di ba? Merong cables na naka-attach diyan, yung CD attached at D, yung AB naman attached at A. Kung ano yung tension ng CD, cable CD saka cable AB, yan din yung reaction ditong banda. Bale sa point A, yung reaction dyan is equal to the tension in AB to maintain internal equilibrium. The same din sa D. So, we can label this as, let's say, dx, tas ito naman, dy. Now, always yan, since our cables are in tension, acting away from the body, then the reaction would oppose the motion. Bale, yung resultant ng dy saka dx would be acting pa ganyan, again, to maintain internal equilibrium. So, doon din sa kabila, if this is in tension, then AB would be acting pa ganyan. So, essentially, AY is acting upward, then AX is acting to the left. Ayan. Now, since alam natin na yung DX is just the horizontal component of CD, then this is equivalent to CD cosine 35. Ayan. Then, yung DY naman is alam natin na this is equivalent to the vertical component of CD. Magiging, CD sine 35. So, notice na isa na lang yung natin, CD. So, we can take moments about point A to determine the value of CD. So, gawin natin yan. Summation of moments about A equal to 0. We have 16 kilonewtons times 6 meters. Then, 20 kN times 17 meters. Positive pa rin. Clockwise yung rotations ng dalawa. 20 times 17. Ayan. Then, we have minus CD sine 35. This will cause a counterclockwise rotation about point A. Then, yung moment arm niya is itong buong distance, which is 24 meters. 24. Ayan. 11 plus 6 plus 7. Then, for dx naman, CD cosine 35, this will cause a counterclockwise rotation about point A. So, minus CD cosine 35. Then, our moment arm is ito, 6 meters. Equate natin yan to 0. So, solving CD, for a while, MathCAD na lang yung gagamitin ko para mas madali nating ma-type yung equations. Gusto ko kasing makita nyo yung exact values talaga. Anyway, copy ko na lang yan. Then, let's just append the figures mamaya. So, we have 16 times 6 plus 20 times 17 minus CD sine 35. By the way, sa MathCAD, naka-radians yan by default. So, let us define degrees as pi over 180 para ma-convert natin. Ayan. Degrees. Then, moment arm is 24 minus CD cosine 35 degrees. Moment arm is 6. Set natin to 0. Then, let us solve CD. Ayan. So, the result is 23.34. Ayan. Store natin yan, CD. So, once alam na natin yung CD, we can use equilibrium equations at joint C to solve the value of angle X. So, tingnan natin. At joint C, we have this free body diagram. 20 kN yan. Joint C, then this is BC. BC. Ayan, inclined at an angle X. If this is X, then alternate interior angles, this is also X. Tapos sa kabila naman, we have CD. CD. Ayan, inclined at an angle of 35 degrees. Then, alam natin na yung CD, value niya is 23.34. So, copy ko na lang yung figure. Then, let us establish our equations. Doon na lang din sa MathCAD para ma-solve natin agad. Ayan. So, gagawin natin ngayon, we will sum up forces along X and also along the Y direction. So, for the forces along X, we have negative BC. To the left kasi yan, yung component niya, BC, then cosine of the angle X. Ayan, in degrees. Then, plus CD. Yung component ng CD is acting to the right. We have CD cosine 35 degrees. Ayan. Then, equate natin to 0. This is our first equation. Then, for the second equation, we will sum up forces along Y. So, we would have BC sine of X degrees. Then, plus, upward yan, yung dalawa, BC saka CD, yung components nila. So, CD sine 35 degrees. Ayan. Then, we have 20 kilonewtons acting downward. Equate na lang natin yung upward saka downward na force. So, equals 20. Ayan. Ito yung dalawang equations natin. Notice na we can isolate BC cosine X and BC sine X. So, for the first equation, we can rearrange it as ganito. Move natin yan sa right side ng equation. Then, equate natin sa CD cosine 35 degrees. Ayan. By the way, yung CD, meron ng value 23.34. So, this part is already a constant. Then, for the second equation, we have BC sine X degrees. Isolate natin. Then, equals, merong 20 dyan. 20, then, ito, magiging minus na yan. Pag nilipat natin sa kabilang side, minus CD. Ayan. Notice na, itong dalawang equations, yung pwede natin gawin dyan is to divide both of the equations. Notice that if we have equation 2, then divide natin by equation 1. BC sine X degrees, ito na lang. Ayan. Pag i-divide natin yan, yung dalawa, then magka-cancel yung BC. Diba? Magka-cancel yung BC, then sine over cosine would become tangent. So, ito yung gagawin natin. Tangent of X degrees would be equal to this expression, ayan, divided by this one. So, yung CD is, again, 23.34. We can now solve the angle X. So, solve X. Ayan. Solving X, we have 19.08 degrees. This is our answer for number 1. I mean, for the value of angle X. Ayan, 19.08. Now, to solve angle Y, you have two options. You can apply the method of sections by cutting AB. Or pwede rin, you can solve AY and AX. Then, automatically, yung AY saka AX, yan yung vertical and horizontal components of AB. Ayan. Then, we can now solve the angle Y. So, ganito yung figure natin. Ito yung resultant ng AX saka AY. Inclined at a certain angle. So, since AX and AY, the same lang sila sa components ng AB, then, the value of angle Y is also equal to this one. Ayan, this is also angle y. So, we can consider the whole system, then just sum up forces along y and also along the x direction. Then, solve natin yung value ng ax saka ay. So, ngayon, considering the whole system, copy ko na lang ulit. Ayan. We can sum up forces along x and y. So, to solve ay, sum up forces along y equal to 0. Ayan. So, we have ay acting upward, positive. Then, 16 and 20 both acting downward. Minus 16, minus 20. Then, plus dy, which is CD sine of 35 degrees. Ayan. Equal to 0, then we will solve ay. Ayan. So, we have 22.613. Then, summation of forces along x naman equal to 0. We have ax acting to the left, negative. Then, this will just be equal to dx, or essentially, ano na lang, since ax and dx are the only horizontal forces acting externally, we can just equate them. Ax is equal to CD cosine 35 degrees. Ayan. So, we would get 19.119. So, store natin yan sa ay. Then, ito naman, store natin sa ayan, nakastore na yan sa ax. So, to solve the angle, ito yung magiging force triangle. Ayan, ay, yung vertical, horizontal is ganito na lang. Horizontal is ax. Ayan. Ito yung resultant, equivalent to AB. Then, solve natin yung angle na yan. We can use the tangent function. Tangent of theta equals opposite ay divided by adjacent ax. So, arctangent na lang ng ay over ax. So, arctangent ay over ax. But don't forget to convert this into degrees. Since again, yung makukuha mo dyan is naka-radians pa yan, yung 0.869. So, multiply natin by 180 divided by pi. 180 degrees over pi. Ayan. Sa calculator mo, wag mo nang gawin ganyan. Dito lang sa MathCAD. So, our answer for the angle theta or angle y, ito yan. 49.786. In your calculator, automatic lang. Bale, arctangent of 22.61 then divided by 19.11. Or 19.12 na lang. Ayan. 49.78 approximately. Ayan. Now, before we solve the length of the cable, let us explore the other method wherein we don't use any equilibrium equations, but we can still obtain the value of angle y and the value of angle x. So, ito yung gagawin natin. Copy natin ulit yung figure. Then, what we will apply is Varignyon's theorem. Notice na yung external loads natin follows a parallel force system. Yung 16 saka 20, both acting vertically, so parallel yung dalawang forces. Therefore, we can obtain the resultant of these forces. Yung magiging resultant niya is just the sum of the two forces. We have 20 plus 16. So, this is going to be 36 kilonewtons. Now, what we want to solve is the distance from point A. Let this be our reference axis. From point A, solve natin yung distance ng resultant from point A, measured from point A. So, by Varignon's theorem, we have resultant times, let's say, bard x is equal to 16 kn times the distance going to the reference axis, we have 6 meters, then plus 20 kn, then yung distance niya from the reference axis is 11 plus 6, which is 17. Ayan. So, masosolve natin yung bard x. So, copy ko na lang dito. Ayan. 36 bard x equal 16 times 6 plus 20 times 17. Solve x. So, we would get 12.11 approximately. So, yung resultant pala na 36 kN is acting 12.11 meters from A. So, sabihin natin nasa point na yan. 12.11. Ayan. So, if this is 12.11, then this remaining distance would be equal to 24 minus 12.11. So, this will give us 11.89. 11.89 meters. So, now, we will try to solve angle x and angle y. Now, after mong ma-determine yung location ng resultant, what you can do is, dito sa extreme ends, sa point A saka point D, kung saan located yung supports, you can extend the following lines, yung AB saka CD. Ayan, extend natin yan. Saka ito rin. Notice na meron silang point of intersection somewhere. Ayan, yung point of intersection nila is andito. Now, at this point, dyan mag-a-act yung resultant, which is 36 kilonewtons. Again, bard x is 12.11. Ayan, dyan mag-a-act yung resultant load. Ibahin natin yung kulay. 36 kN. And then this will act at a distance 12.11 from A. So, ito pala, move lang natin to. Ayan. Let us project a line from this point. Extend natin dyan. Ayan. Ito yung 12.11 meters. The remaining distance is 11.89 essentially. So, di ba, nakuha natin yung angle y kanina. The value of angle y is saan na yan? Ito, 49.786. Now, we can also obtain this value just by using geometry. Ayan, di ba ito yung angle y? Ito, alam natin na 6 meters yan. So, if we project a horizontal line from point D, ayan, then we know that this distance is equal to 6 meters din. Ayan, 6 meters. So, yung isosolve natin is this distance to be able to determine the value of angle y. Now, we can label this as, sabihin natin h1. To solve h1, we can use this distance. Ayan, ito yung triangle na i-consider natin. Ayan, yung triangle na yan. Yung base niya is 11.89. Then, yung height niya is h1. Then, the value of this angle, since 35 degrees yan, then this is also 35 degrees. Ayan. So, we can use the tangent function, opposite over adjacent. We have tangent of 35 degrees equals h1, opposite, tas yung adjacent is 11.89. Solved using Varignone's theorem. So, solving h1, we have tangent 35 times 11.89. We would get 8.325. This is in meters. Now, after getting h1, then we can solve this height. Then, this horizontal distance is 12.11. So, makukuha na natin yung angle y. Diba? I hope agree lang. We can consider this triangle. Ayan. So, tangent of angle y is equal to opposite over adjacent. Yung opposite na side is 6 plus h1. So, 6 plus 8.325. Then, yung adjacent side niya naman is 12.11 meters. Ayan, yung distance na yan. So, to solve angle Y, arctangent na lang. Arctangent, then we have 6 plus 8.325 divided by 12.11 equals, we would get 49.79. Then, this is in degrees. So, di ba, nakuha natin yung angle Y without using equilibrium equations. Ito yan, 49.79. Now, meron lang discrepancy since nag-round off kasi tayo. Ayan. So, 49.79. Now, sir, paano naman yung angle X? How can we solve it just by using geometry pa rin? Walang equilibrium equations. We can also solve that angle. So, what we will do is, we have to first solve this distance. Project tayo ng line from point B. Vertical line. Then, extend natin to. Ayan. Diba, masosolve natin yung distance na yan using the angle Y that we have obtained. 49.79 degrees. Now, ito yung base niya. Yung base niya is 6 meters. Then, we can solve this height. Sabihin natin, this is H2. Ayan. To solve H2, we can use the tangent function pa rin. Tangent of 49.79 degrees equals opposite H2 divided by the adjacent side. The adjacent side is 6 meters over 6. So we have H2 equals 6 tangent of 49.79. Ayan. So we would get 7.1 approximately. Now, if this is 7.1, then we can solve this distance. Itong maliit na distance na yan. From here, going to point B. 7.1 yan. Ito naman, 6 meters. So, 7.1 minus 6, that will give us 1.1 meters. Ayan, 1.1 meters. So, yung next natin gagawin is from point B, we will extend our horizontal line. Ayan, pa ganyan. Then, notice that we can consider this triangle. Now, the base is equal to 11 meters. What we need is this height. Now, this height is obtainable. Paano yan natin makukuha? Diba, alam natin na 7 meters yan. 7 meters, then this is 35 degrees. So, we can project a line here. Ayan, project tayo ng line dyan. Then, this height is solvable. Since meron tayong angle, meron din tayong adjacent side. So, label natin yan as, sabihin natin, H3. So, we will still use the tangent function pa rin. Tangent of 35 degrees equals H3. Opposite, adjacent niya is 7 meters divided by 7. So, H3 is equal to 7 tan 35, which is 4.9. So, if this is 4.9 meters, and we know na this is 1.1 meters, then subtracting both, H3 minus 1.1, ito yung magiging height ng triangle na yan. Ayan. So, using the tangent function, we can solve the angle X. Tangent of X degrees would be equal to opposite. Again, the opposite side is 4.9 minus 1.1. Then, yung adjacent niya is this one, 11 meters. Divided by 11. So, arctangent of 4.9 minus 1.1, then divide natin by 11. So, press equals, we have 19.06. Ayan. So, checking our answer, ayan, 19.08. Now, merong discrepancy na 0.02 since nag-round off kasi tayo ng values. If we didn't round off any value, then exact talaga. Mag-equal yung dalawa. So, ito yung dalawang options mo to solve angles X and Y. Now, for the total length of the cable, madali na lang kapag nakuha mo na yung angle X and Y. What we just need to do is, alam natin na itong AB, BC, and CD, yan yung hypotenuse ng triangle. So, alam na natin yan. This is 49.79. Tas ito naman 19.08. Yung exact na lang, galing sa MathCAD. Ayan, 19.08 and 49.79. So, to solve the total length, just get the length of the hypotenuse. Draw natin yung, let's say, segment AB. Ayan, same relationships lang para sa BC and CD. So, for segment AB, meron siyang angle dito, 49.79. So, to solve the length, we have the adjacent side, which is 6 meters. Then, we want this length, the hypotenuse. So, what relates the adjacent side and the hypotenuse? Diba, cosine, adjacent over hypotenuse. So, cosine of 49.79 is equal to adjacent 6 divided by the hypotenuse AB, or ano na lang, length of AB, LAB, ayan. So, isolating LAB, we would have 6 divided by cosine of the angle, 49.79. So, it would also follow na for BC, we just divide 11 by cosine of 19.08. Then, for CD naman, 7 divided by cosine 35. So, the total length would be equal to this value, length of AB, then plus 11 meters divided by cosine 19.08, then plus ito, 7 divided by cosine of 35. Ayan. So, this will give us 29.48 meters. Ito yung total length ng cable. Ayan. So, again, yung additional concept natin ngayon is Varignon's theorem. Then, take note na you can apply this for any segmented cable. For example, so kapag ganito yung configuration, still the same, you can apply Varignon's theorem, locate the resultant from a reference axis. Then, for example, yung nakuha mong resultant is andito. Sabihin lang natin. Ito yung barred X. So, what you can do after is, you can extend this line. Again, yung nasa extreme end lang, yung nasa supports, pwede mo siyang i-extend pa ganyan. Tapos, ito rin, extend mo pa ganyan. Yung location ng resultant will be andito. Teka lang. Mali pala yung estimation ko. Ito yung location ng resultant. Then, dito mo na ilalagay yung resultant force. Ayan. Resultant force, which is the sum of these forces. So, what you can do next is, sabihin natin DE yan. To solve the tension in AB and DE, you can just consider this entire system. Ayan. Parang dalawang cables na lang. Ito yung cable AB, ito naman yung cable DE by the principle of transmissibility. Ayan. So, knowing this concept, you can simplify a lot of calculations involving segmented cables.